What's up? Hey, what's up, guys? What's going on? So, I'm gonna solve two parallel circuits here. One parallel circuit with two loads, the one that you see up here, and one parallel circuit below with three loads. And let's solve the one with two loads first, and we'll go over it. Let's put some numbers up here. Let's say the total voltage, the voltage source is 20 volts. Let's say R1 is 2k ohms. Let's say R2 is 3k ohms. Before we actually go around and solve the circuit, let's put up some facts about parallel circuits. All right. So fact number one. So we'll call it parallel circuit facts. Parallel facts. So fact number one. Voltage remains the same across every load. Voltage is equal in every load. Alright. Fact number two, the current, which is I, will change based on resistance, based on load's resistance. And finally, total resistance, Req, the total resistance. By the way, we call this Req, equivalent resistance. Call it Req. This is very similar to RT in a series circuit, but in a parallel circuit, we call it Req. Total resistance, Req, in a parallel circuit will be lower than lowest resistor. Lowest resistance. So we'll get into that. We'll get into all of these pieces. The first thing is the voltage remains the same. So if you know the voltage remains the same, why don't we do this first? Why don't we just label all the voltages across every load? So if we know that the total voltage is 20 volts, we know the V1 will also be 20 volts. Let's label it 20 volts. We know V2 will also be 20 volts. Right? These two voltages will remain the same. So now let's find Req first. Req or RT. Remember, in a parallel circuit, we call it Req. So I'll call this, my bad, I'll call this Req. Use a black ink for this. Now the formula for parallel circuit to find Req is the following. There's several formulas for this, and we'll go over each one. R1 times R2 divided by R1 plus R2. This is called product over the sum formula, POS. Product over the sum formula. Another formula for Req, and we're going to be using this one to find Req. And this is a universal formula. This can be used for any number of loads. 1 over R1 plus 1 over R2. So if you had 3 loads, right? If you had 3 loads, it would be 1 over R3 here. Like the one that is down here with the 3 loads, we're going to be using this formula, but we're going to have 3 resistances here. All right. There's one more. Req is equal to R over N. Right? This is a very simple, easy formula, but this is really in situations when all the loads are the same. But our focus is going to be on this formula here. We'll be focusing on this one right now. You can also use this formula, but this is only when you have 2 loads. So we can actually use this formula to help us find Req in the circuit but we're gonna be focusing on this one. This is the universal formula, and let's get practice using this one. All right. Also, you should have your calculators out, and in your calculators, look for the button, the inverse function, which is going to be either looking like this, a button that has 1 over x, or a function that looks like this, x to the negative 1 power. These are your inverse functions. All right. So you should have in your calculator a function like that. We're going to be needing these buttons to solve this parallel circuit. All right. So guys, let's get to it. Now, feel free to pause and review things as you guys need to. It might get a little cluttery, so I'm going to move the things around. I'm going to move things around here for us. Okay. So what are we looking for here? We have to find, we're going to find REQ. Remember, REQ is just like RT in a series circuit. Don't get it confused. All right, just the formula is different. We're going to find REQ. We're going to find IT. We're going to find I1. We're going to find I2. We'll find PT, P1, and P2. So none of the formulas are different here. What we use in Ohm's law and series circuits applies except for REQ. REQ is the only thing that's new here. Everything else is the same from the series circuit lesson. All right, let's get to it. Let's find REQ first. I'm gonna use black here. So REQ is equal to 1 over R1 plus 1 over R2. Let's substitute the values. 1 over R1 is what, 2K? What's R2? 3K, right? And if you work this out, you should get, let's see, I have the answers worked out here. You should be working out in your calculator as well. My answer came out to 1200 ohms, right, or 1.2k ohms. So here's the key thing. If you got a decimal answer, that means you have to inverse it one more time. So here's what's going on, guys. So you plug in 2k in your calculators, right? And then you press the inverse function, plus symbol. Plug in 3k in your calculators, right? Press the inverse function. Then you press the equal button. And then you press the inverse function one more time. All right, you gotta press it one more time, and then you get 1200 ohms or 1.2k ohms. So altogether, you're pressing the inverse function 3 times altogether. All right, cool. So let's label the REQ at this right place. This is 1.2k ohms. All right. Now let's find IT. IT is going to be my Ohm's law, VT over RT, right? Remember, this is RT, but I'm going to call it REQ because it's a parallel circuit, so the name changes. So my VT is 20, my REQ is 1200, and what did you get? What do you get for your current? It's sort of kind of a weird number, right? I got 16.6 milliamps, and the 6 repeats itself. This is going to be 16.6 milliamps. I'm going to label it. You see what I'm doing here, guys? Once I find something, I label it immediately. Okay, this is going to help me in the long run, I promise you. So make sure you label your circuits accordingly. And then you box your final answer. Alright, that's my IT. Let's find I1. Right, remember, I1 plus I2 should equal IT. So my I1 is V1 over R1. Look at the subnumbers. The subnumbers must match here. My V1 is 20 volts. My R1 is 2k ohms, right? And what do I get for I1? Well, I got 0.01 amps or 10 milliamps, right? 10 milliamps. That's my I1. So if my I1 is 10 milliamps and my IT is 16.6 milliamps, I know my I2 should be 6.6 milliamps, all right? But let's work it out and let's see what's going on. So now let's find I2 next. My I2 is going to be V2 over R2. My V2 is 20. Remember, the voltage does not change, right? It's the same voltage from the total voltage. And that voltage was already given. And my R2 is 3K, right? 3K. What do I get? Well, you guessed it. 6.6 milliamps, right? 6.6 milliamps. That's what you guys should get also. Now, let's say you got 6.5 milliamps or something close to it. That's fine. That's okay. That just means that you rounded it up a little differently. Not a big deal. Not a big deal. So what I'm going to do here, guys, is I'm going to label my currents everywhere. All right? So just once you find something, make sure you label it and label it in the right place. Where my V1 and R1 is, my I1 is going to be. So my I1 is 10 milliamps. And my I2 is 6.6 milliamps, right? My I2 is 6.6 milliamps. All right. Now let's find the powers. Power formula has not changed. It remains the same, right? PT, P1, P2, and P3. I'm just going to move this circuit a little bit back. Okay, move it a little bit far back. Okay, good. There you go. All right, so let's do it. So my power my PT is going to be, I'm going to use a simple formula, VT times IT. VT times IT. Alright. My VT is what? 20, right? 20. And my IT is what? 16.6 milliamps. Right? So, if I work that out, I should be getting, again, it's a little strange. The number is a little weird, but about 333 milliwatts. Alright. Now, I'm doing everything in milliwatts and milliamps and stuff. So, you guys should understand what that means by this time, by now. That's my PT. Let's do P1 and P2. Remember, PT is equal to P1 plus P2. So what we get for P1 and what we get for P2, we can add them up to equal PT. So P1 is going to be V1 times I1. I'm just using the simple formula here, guys. If you want to use I squared times R, you can use that too. Just make sure that the sub numbers are matching. So it's got to be I squared 1 times R1. Alright, so V1 again is 20 times, what's I1? I1's 10 milliamps, right? So it's 10 milliamps. And what do I get for P1? Well, it's 200 milliwatts. 200 milliwatts. 200 milliwatts. That's what I get. Or 0.2 watts, right? Let's do P2. My P2, same thing. I'm going to use V2 times I. And my, V2 is 20. Same as the total voltage. And my current is what? What's my current here? 6.6 milli? 6.6 milli. And what do I get? What do I get for P2? Yep, you guessed it, guys. 133 milliwatts. 133 milliwatts, or 0.133 watts. That's it. So we just solved for a parallel circuit, two load parallel circuit. I'm gonna pause it here. I'm gonna do another little video of solving this guy with the three loads. All right, so I'll see you guys soon.